Hey guys, so today we're looking at Algebra 3's first section in Chapter 4. And this whole chapter is a lot of review. It's a lot of baseline algebra that you need to know how to do to move on and solve harder types of equations and harder types of simplifying. And we're going to start with exponential functions. And then we'll move into logarithmic functions, and then we'll move into graphing them and solving. The solving part is the most important part in this chapter because later on I'm going to treat you all like you can solve these functions very easily, or these equations very easily. And the mechanics behind it are not very difficult. It's more of the same. Like, just like you know that when you see this, right, you know to divide by 4, right? It's just something you know how to do to get x by itself. You're going to need to know the same sorts of things for exponential equations and logarithmic equations, and they're all just the same sort of thing. Here you'll divide, and exponential functions you'll change to a log, and log functions you'll change to an exponential. It won't be anything complicated so long as you don't create like mental blocks. So first things first, definition of exponential functions, then evaluating exponential functions at specific values, and then graphing exponential functions, and then determining transformations of exponential functions. So let's go ahead and get into it. Now, all of this is going to be review, okay? So if I were you, I would be holding off on what it is you're writing until I let you know, because a lot of this you'll probably, like, it's really basic stuff. So exponential functions take the form f of x equals b to the x, right? Where b is called the base. So the base is the number that is being raised to the exponent, strictly the single piece that is being raised to the exponent. So just to give you a couple of examples, here the base is 2. Here, the base is 2. It's not -2, it's 2. In this case, this is, wow, if I can, this is a base of -2, right? There's a big difference here. The exponent only applies to the number it is directly touching, and if it's touching a set of parentheses, then it applies to everything in the parentheses. Okay, that's how it works. Functions cannot have bases that are negative, 0, or 1 if you still want to call them exponential functions. You could have these as bases, but they would not make exponential functions. And examples, which of these are exponential functions? So remember, exponential functions can't have bases that are negative, 0, or 1. And it needs to be a number raised to a variable. All right, so is this an exponential function? If you said yes, you are wrong. And the reason is we have an exponent and we have a variable, right? But the variable needs to be in the exponent. That's a big thing. The variable needs to be up here. And the base needs to be a number that is not negative, not 0, and not 1. So the base, which is x, needs to be a number for it to be exponential. And your exponent is 2 in this case, but it needs to have a variable in there. How about the next one? Is this an exponential function? The answer here is yes. You've got a number raised to a letter. And the number is not 0, it's not negative, and it's not 1. So we're good. 10 is the base, x is the exponent. How about j of x? Is this an exponential function? Think about it. The answer is yes, this is an exponential function because you've got a number. The number happens to be 1/2, but that's okay. And then your exponent does have a variable in it, so you're good. So this is exponential. Finally, is this exponential? The answer is no, because the base is negative. So negative base. Okay. So, if in case you've forgotten, e is a constant in mathematics, and it is referred to as the natural base, or a natural the natural number log, right? So, or what am I? No, it's the natural constant e. That's what it is. So it approximates to 2.718. That's what it approximates to. So anytime you see e, just think that it's close to 2.718. Just like you might think that pi is close to 3.14, right? E is close to 2.718. It's the same thing. It's a number that is a mathematical constant. So a function like f of x equals e to the x minus 2 quantity plus 1 is an exponential function, since the base is a positive number that's not 0 or 1, and your exponent has a variable in it. So this is an exponential function. All right, I just wanted to introduce that. So e is an okay base. Now, here we have an example. I would not write this example down because it takes up quite a bit of space. I would maybe write down this. I don't know. I would just probably write down this and then state that x represents hours. So I'm going to read it to you. The exponential function f of x equals 42.2 times 1.56 to the x models the average amount spent f of x. So f of x is the amount spent. In dollars, so it's the dollar amount spent at a shopping mall after X hours. So this is X is hours. What is the average amount spent to the nearest dollar after 4 hours? So what do we have to do here? It's wanting to know what is the average amount spent. Well, the average amount spent is f of x. So we're trying to figure out what f of x is when 4 hours have passed. So you need to plug in 4 into x and solve it. So f of 4 would equal 42.2 times 1.56 raised to the 4th power, which is approximately, pull out our handy dandy calculator, if it will turn on. Hey, turn on. 42.2 times 1.56 raised to the 4th power. The average amount spent after 4 hours at this shopping mall is $249.92. Rounded to the nearest dollar would be 250. That is not a lot of money spent at this shopping mall. It must be like the, who knows, 4 hours and only making $250. That's, I don't even know. So, moving on. Graphing exponential functions. The easiest thing to do is to use your calculator's table feature to do this for you. If I tell you to draw a graph and you have a calculator, using the table feature will be the easiest thing to do. But you should absolutely know what common exponential functions look like. So here's the difference. It is called an exponential growth function if the base is bigger than 1. So here your base is 2. 2 is bigger than 1. So this right here is a growth function. Growth functions look like this. This is what growth functions look like. Sometimes they may be more, widened. Sometimes they may be steeper, but they are all growth functions if they look like this. If as x increases, y increases, they are growth functions. That's the key takeaway. As x increases, y increases. Those are growth functions. So if you look, as your x's march on to the right, your y's go up, 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 up. It might look pretty like there's not much going up here, but they are. They're slowly rising. Then, if your base is a fraction between 0 and 1, so this is a fraction. If you have a fraction base, you have decay function. And a decay function, as x increases, y decreases. So as x increases, y decreases. So as you're moving to the right, you're moving down consistently. And it may look like it levels off here, but it doesn't. It gets closer and closer to the x-axis. All right? Moving on. Transformations of exponential functions. Now, if you remember, back at the quadratics, we did this. We had this formula. We had A, H, and K. They're going to do the same thing. A, H, and K are going to do exactly the same thing. So A, in the quadratic, A would vertically stretch the graph, or it would reflect it over the x-axis if it was negative. It's going to happen the same exact way here. If you saw a minus number inside the parentheses, it moved it to the right. Same up here. If you see a minus number up here in the exponent, it moves it to the right, that number. If you see a plus inside the parentheses, it moves it left. A plus up here moves it left. These are the same transformations, guys. If you're the type of student who is just putting information in one ear, storing it there for 2 weeks, and then purging it, you're just gonna have to keep relearning all this stuff. I encourage you to actually retain the information. So all of these transformations from different function types will all work the same. So an x minus h moves right h, an x plus h moves left h. A negative x will reflect over the y-axis. So that's in the event that your exponent is negative. It'll reflect over the y-axis. A plus number at the end moves it up, and a minus number at the end moves it down. So I'll just keep it here for just a second, that if you guys want to pause the video and write this stuff down, you can do so. And move on. Now, your parent function will always be where b is the base of your, where always be y equals b to the x. I missed something here. Your parent function will always be y equals b to the x, where b is the base of your problem. That's it. Every parent function is always going to have y equals number to the x. The only thing that's going to change, right? I tell my students this, and it's like their brain doesn't want to believe that it's so simple. But it really is. Every parent function to exponential functions is always y equals then whatever your base is. That's the only thing that'll change, is whatever your base is, and then to the x power. The x power will never change. Even if you've got right here x plus 3, in the parent function it's just going to be x, all right? So it's always going to be y equals number to the x power, where the number is your base. Now, y is a simplification. Certain functions are called f of x, certain functions are called g of x. So you should change y based on what you call your function. But y is like the layman terms for f of x and g of x, okay? Now, let's look at this. State the parent function and the transformations of the following exponential functions. We've got f of x equals 2 to the x minus 3. So you guys tell me, what is your base? What is the base of this function? If you said 2, you're correct. So the parent function is f of x, aka y, equals your base, which is 2, to the x. So this is your parent function. F of x, which is this name, equals 2, which is your base, to the x power. Okay. Then, what are the transformations? Well, let's rewind here. I will highlight everything that is in the parent function. So we've got f of x equals 2 to the x power. Everything that is not highlighted will transform the graph. So the minus 3 here, this minus 3 transforms the graph, and we have to figure out how. So if you want to take a stab at this, go for it. If you need help, scroll back up and look at your notes, figure out where this was on the formula here, where a number would have shown up if it looks like it's right here at the end, and then what a negative would do, and see what you get. If you said down 3, you're correct. The minus 3 at the end moves it down 3. Now, moving on to the next problem. You guys try to work this problem out. Write the parent function and then write the transformations. There are 2 transformations here. Okay, so the parent function is g of x equals 2 to the x. Because 2 is the base, that's the base, to the x power. And this stays the same. So everything not highlighted is going to transform the graph. So the 3 is going to transform the graph, and the plus 3 is going to transform the graph. So I'll keep the highlighting consistent. So what is this 3 going to do? Any ideas? If you said vertically stretch the graph by a factor of 3, then you are incredibly correct. Basically, it's going to take your curve. This is an exponential growth function, so it's going to take the growth function that looks like this, and maybe like this level of steep. No, it would look something like this. All right. It would take a graph that looks like this, and instead transform it to look like this, where it's steeper. Okay, that's the idea. So steeper by 3, or a vertical, I like to say a vertical stretch by a factor of 3. Vertical stretch by a factor of 3. Then the plus 3 over here. What do you think this does? Any takers? Always try to guess. Remember, always try to guess even if you don't know the answer. This moves the graph left 3. Okay. There's your homework. Those are the instructions for the homework problems. For 11 and 16, no special instructions, just follow along in the book. And from 25 to 32, only state the transformations, okay? So there you go. If you have any questions, please ask them, and do your homework. Please do your homework. Don't procrastinate. Do it the day I assign it, in the class period that you watch the video. A lot of you have honestly, a lot of you have a very terrible student ethic here in this class, because I give you the freedom to procrastinate. I give you the freedom to skip lessons. I don't hold your hand, and I expect you to be responsible. And some people can't handle it, and some people can. So if you're doing poorly right now, towards the beginning of the second 9 weeks, you need to reevaluate what it is you're doing in here. I promise you, you have all of the tools to succeed in this class. So, do your homework. Don't be lazy bums.